Hey guys, it's Miss Johnson and I'm here to bring you our lesson video for Unit 7 Notes 5. Today we're talking about finding the z-score from the normal curve, just doing some more examples of how we calculate that z-score and where it falls on our normal distribution. So remember that the z-score stands for, or the z-score is measuring the number of standard deviations a given score is above or below the mean, and that is the z-score formula that we're going to use. Now we've seen that formula for a couple of days now, but we're going to work with it a little bit more today. So first, let's just do a couple of basic examples. It says, find the following z-score. Find the z-score that represents the 20th percentile. So we're just seeing some things in a couple of different phrases here. So what that means is, in the 20th percentile, I'm looking at a probability of 0.2000. So I'm going to look inside my table, and I'm going to find the closest p-value. So that's one thing. Find the closest p. That's a D, by the way. P-value. Find the closest probability value to whatever you're looking for. So it's the closest to 0.2000. The z-score gives me a z of negative 0.84. Remember, the bottom half of the data is on the negative z-score side, so 20% is in the bottom half. For Part B, find the z that represents the 60th percentile. 60th percentile means that it's 0.06 or 0.6000. And again, I'm going to look for the closest thing, and my closest part, or my closest z-score, is 0.25. So I look for the probability of 0.6 within the table, and what's the z-score that's closest to it. The 95th percentile, or in other words, 0.9500, this one is one that's close, that's right between two. I think it's like equally between two. So this one you could call it either, and I would mark either one correct. 1.64 or z is equal to 1.65. So either one of those could be correct. You could technically go out to a third decimal place and call it 1.645, but we don't do that very often. You can just pick either one of those and both answers would be correct. Some more different verbiage here that we've seen. Find the following z-scores. Find the z that represents the first decile. If you think decile, a decile is every 10%. Or every 10th, if you will. So the first decile would be 0.1, which means I want 0.1000 in the table, and the closest z that is there, or that's closest to 0.1000, is negative 2.33 in the table. Find the z that represents the third quartile. If you think quartile, this should remind you of the box and whisker plots that we did back in Unit 1. Quartiles are every 25%. Remember, box and whisker plots were split into 25% equal increments. So quartile is 0.25 or 25%. So if you want the third one, you're looking at the third quarter, which is 75%. So in other words, 0.7500. So your z that's closest to 0.7500 is 0.67. Positive side because it's the upper half of the data. All right, so now let's take a look at example 3. Find the z with 40% of the observations to the left of it. 40% of the observations to the left of it. So that means I want p equaling 0.4000. So I look for that in the table, and the closest one that's near 40% is the z-score of negative 0.25. In the next one, find the z with 65% of the observations to the left of it. When they say to the left of it, what they mean is if you're looking at this normal distribution curve, there's your mean. If you want 40%, that means you're like right about here, because remember, the mean is always that 0.5 mark. So here's 0.4, and to the left of 0.4 is underneath the curve, under the curve. And that's what the z-scores are always measuring, underneath the curve. So if I want 0.6500, that means I'm looking at like above here somewhere. To the left is down again. So I just look for 0.65 in the table. P is equal to 0.65. Oops, too many zeros, sorry. 0.6500, and my z that's closest to that is 0.39. Okay. So under the curve or to the left of the curve, to the bottom, less than, any way you think of it, it's underneath whatever your line is for the probability. When we look at part C, in part C it says find the z with 20% of the observations to the right of it, which is above the curve. So here's how that changes things. A second. So if this is my normal distribution table, there's my mean. I want this guy right here, where this is 0.2. But my z-score table measures this side. So what you have to know, because it measures everything to the left or underneath. So if you want above the curve, what you need to know is how much is over here. Well, the way you get that is take the 100% minus 20%, and that's equal to 80%. So really you're looking for where p is equal to 0.8000, or again, the closest one to it, and the z-score that's closely associated to 0.8000 is 0.84. So again, when you see this to the right, you're looking at above the curve. You need to take 1 minus that percentage, or 1 minus that decimal version, to get the decimal version to the left of it, because the z-score line measures everything to the left. Let's do a few more that are similar to that. It says in the normal distribution, find the z-score that cuts off the top. So again, if I'm cutting off the top, here's my normal curve. We're going to draw a lot of pictures today, by the way, so you're going to get good at kind of rough sketching that bell curve. So here's my top. Let's say I want the top 30%. So the top 30% is going to be right about there. This is the 30%. So then the question is, what is the area underneath the 30%? Because you have to measure, or the line, I should say, the z-score line measures everything underneath it. So I need to take the 1.00 and subtract the 0.3000, and I get 0.7000. Or in other words, 100% minus 30% is equal to 70%. Either way you think about it, this is the decimal you're looking at. The z-score that's most closely associated to that is 0.52. That's my z there. So I look for 0.700 in the table. I find the z that's closest to it if it doesn't actually exist in the table, and in this case it's 0.52. If I look at what's the z-score associated with the top 7%, this is a tiny little guy up here, 7% there, which means what's all of this stuff down here? What's all of this? Everything except that top 70%. So I have to take 100%, subtract, or no, sorry, not top 70, top 7. Take 100%, subtract the 7%, and I get 93%. Or in other words, my probability needs to be 0.9300. So you find the z that's closely associated to 0.9300, and you have 1.48. Makes sense because you're a lot farther away from the mean. So that's a z-score of 1.48. This was a z-score of 0.52. Both are on the positive side because both are measuring percentages that are above 50%, but the 93% is much farther away from the 70. So my z-score is a lot higher. Okay, now here's where life gets a little bit tricky. So in example 5, it says in a normal distribution, find the z-scores that cut off the middle. Ooh, okay. So here's where we have to do a little more work to figure out what we're looking for. Notice that it says find the, ooh, and it doesn't, it should, I'm sorry, find the z-scores. You're going to have two z-scores here. That should be z-scores plural, and I'm sorry that doesn't say that. Find the z-scores that cut off the middle 20%. So again, here's your mean. Mean is equal to 0. If you want the middle 20%, that means you want about this. Okay, that's what you're looking for. You're looking for what is this z-score and what is that z-score that's going to cut off the middle. So here's how you find out. What you need to know is, what is this? What is the area underneath that bottom part of the curve? And the other thing you need to know is, what is this? What's the area above that top part, or in other words, measure below this line right there. So if 20% of the data is what I want, you have to think of what are you cutting off, okay? You're picking the 20% in the middle, so how much data are you cutting off? If you think of 100% of the data and you subtract 20% of the data, that means you're taking out 80% of the data. Now, recall that the z-score curve, the normal distribution curve, is symmetrical. So what you see on this side, it matches what's over here. So I can take that 80% and cut it in half. Take the 80% and divide it by 2, and you get 40%. So that means this piece right here is 40%. This piece right here is also 40%. Makes sense. I have 40, 40, which gives me 80, and then the middle 20 that I want, which gives me 100. So then I've got the whole curve. So this piece is actually not so bad because this line right here is the 0.4000 line. So you need the 0.4000 z-score. The z-score that's closely associated to 0.4000 is negative 0.25. It's this one that's a little bit trickier. You have to think of the fact that this is 40% of the data plus 60% of the data, and that's that mark right there. So this is actually 0.6000. Did I say that right? 40% of the data plus 20% of the data is 60% of the data. So this line right here, 60%. So the 0.6000 z-score is positive 0.25. Now, when you think in your brain, use your logic. Those are the two z-scores that are cutting off the middle. When you think in your brain using your logic and you ask yourself or remind yourself, hey, this is symmetrical. So I'm cutting off the middle, which means I'm equal distance from 0 in either direction. Since I'm equal distance from 0 in either direction, they better be the same z-score, just one negative, one positive. And boom, that's what you get. Negative 0.25, positive 0.25. So really, theoretically, you could find this one, which was going to be the negative one because it's going to be on the bottom half of the data, and then also list its positive version. If you want to be super careful, draw yourself this picture every time and make sure that you find the right values. So let's do this again on the next one. So again, there's my curve, there's my line. I want the middle 36%. It's kind of an awkward number, but here we go. So this is 36%. So the question is, how much data is over here and how much data is over there? Well, if you want the middle 36%, you take 100% of the data and subtract 36% of the data, because that's what you want. How much is left? 100% minus 36% is 64%. Sorry, it took me a second there. So 64% of the data is what you're cutting off. Now, 64% of the data gets cut in half because half of it's here and half of it's there. So 64% divided by 2 is 32%. So you want a p-value of 0.3200 for this one. And then this one right here is that plus that because you're marking off that and the piece in the middle that you want. So 0.32 plus 0.36, which is 0.68. So that's your other p-value that you want. Oops, sorry, 6800. So now I should check I'm going to check the z-scores of these, and I should find that the z-scores are equal distance from 0, meaning they have the same absolute value, just one positive, one negative. So over here, the z-score that's closely associated to 0.32 is negative 0.47. And over here, the z-score associated to 0.68 is positive, equal to positive 0.47. So those are the two z-scores that cut off the middle 36%. The middle is definitely the hardest one that you have to do. It's the one that's going to cause the most effort. Okay, now let's just remember that things can be simple. If we go to the next example, in a normal distribution, find the z-score that cuts off the bottom. So we're straight up back at the bottom of the curve. So let's say you're looking at bottom 30%. Here's your 30%, 0.3. There's the bottom of the curve. All you got to do is find the z. So your probability is 0.3000. Look at the z-score closely associated. It's negative 1.88 for the closest one. Bottom 48%. Bottom 48 is really close to that midline, but not quite. Still on the negative side, but very close to 0. So my P is 0.4800, which means my Z is negative 0.05 when I match it into the table. Now again, for every single one of these, I'm looking in the table for the 0.3. I'm looking in the body of the table for 0.300. You may not find 0.3000. You may have to look at the one that is closest to it to get that Z-score. All right, next one. All right, we're going to just look at some real world examples here. It says the length of pregnancies from conception to natural birth among a certain female population follows a normal distribution with a mean of 270 and a standard deviation of 10 days. So mean is 270, standard deviation is 10. It's good to know. There we go. So what percent of the pregnancies last more? Read that verbiage right there. Than 300 days. More than. More than means greater than, or in other words, right side. What that also tells you is you got to do a 1 minus here. Okay. So the first thing that you're going to do, because you want the right side up here. So 1 minus. The first thing that you need to do is you need to take this and this and this, and you need to normalize it to the Z. So I'm going to take 300 minus the 270, and this just goes back to using that formula that we used the last couple of days. 300 minus 270 is equal to 30 over 10. 30 over 10 is equal to 3.00. So now the P for 3.00 is 0.9987. But that's the area to the left. This is the left, underneath the curve. I want above, to the right. So to the right means I need to take 1 minus 0.9987, and I get 0.0013. That is the probability of pregnancies that last longer than 300 days. Now, let's look at the next one, B. How short must a pregnancy be in order to fall in the shortest 10%? Shortest 10%. So shortest tells you that you are on the left side underneath. 10% means your p-value is 0.1000. So since you're going to the left, all you need to do is find the z-score associated to 0.1000. So 0.1000, the z-score is negative 1.28. Now, here's the thing. This is your z-score. This doesn't tell you the number of days, and the number of days is what you want. So this goes back to that other lesson that we talked about, finding the missing x value. So if I know the z-score and I plug it into my formula, I don't know the x, I know the mean, I know the standard deviation. Now, back yourself out to find the x. Multiply by 10. I get negative 12.8 is equal to x minus 270. Oops, sorry, 272. And then I add the 270. 270 plus negative 12.8 is 257.2 days, or in other words, about 257 days. That's a tricky one. You got to use the probability, find the z-score. Take the z-score and plug it into the formula, use algebra to back yourself out of it and solve for x. Whew, that was a good one. Let's take a look at number 8. Number 8. On a recent endurance test, the score obtained by the contestants was found to be normally distributed with a mean of 102 and a standard deviation of 5. The judges have decided to award a trophy to the top 10%, top, keyword, 10%. What is the minimum score a contestant must obtain in order to receive a trophy? So if you want the top 10%, that means you want the bottom 90%. Remember that you need to measure under the curve, not above it. Under the z-score line, not above it. So if I want top 10%, 100% minus 10% gives me 90%. So now ask yourself, to 0.9000, what's the z? Z is 1.28. And what is the minimum score? Means you are finding x. So I need to plug this into my formula again. 1.28 is equal to x minus the mean of 102 divided by the standard deviation of 5, and work your way out of it to get x by itself. Multiply by 5. That gives you 6.4 is equal to x minus 102. Add your 102, and you get 108.4 is equal to x. That's your score. So top 10%, convert it to the bottom, it's the 90%. That's 0.9 in the table. Find 0.9 in the table. The z-score is 1.28. Plug that z-score into the formula. Use algebra to get the x by itself. These are some tough, tough questions, folks. Let's take a look at example 9. It says Professor Rogers has found that the grades on the final exam are normally distributed with a mean of 42 and a standard deviation of 15. If a passing grade is 24, what percent will fail? So find the percentage that is fail, should tell you that it's less than, or in other words, at the bottom. Find the percent that's underneath the score of 24. Now, you have to normalize this first. You don't have a z-score, so you have to calculate a z-score. So I'm going to take the score of 24, subtract the mean of 42, divide by the standard deviation of 15. When I do all that, negative 18 over 15 is negative 1.2. Now find your probability associated to negative 1.2, that's 0.1151, or in other words, about 11.51% will fail. No fancy flipping here because you were already looking at the bottom, which is what's giving you. Okay, if Professor Rogers wants 95% of the class to pass, meaning be above, what should the passing grade be? Okay, so what should the passing grade be? It means that you're finding an X. Yay! So if 95% pass, you need to know how many are underneath it. So in other words, how many fail? 5% fail. So if 5% fail, that's 0.0500, and the z-score associated to 0.0500 is negative 1.64. Now plug that into your formula. Negative 1.64 is equal to x minus the 42, because you don't know what x is, that's what you're trying to find, divided by the 15. Multiply by your 15. 15 times negative 1.64 is negative 24.6 is equal to x minus 42. Add your 42. Your passing score is 17.4. Whew. So you had the percentage above, you want the percentage below. So take 100 minus that. Then find that percentage in the table, get the z-score. Take the z-score, plug it into the formula, get the actual score. So this is like where we are undoing the normalization. You had normalization happening here, but you have to undo that to get yourself back to the original score that you wanted plugged in. All right, we're almost done, folks. We're going to make it, I promise. In example 10, it says all candidates for the job at McGill Securities must take a marketing exam. It is known that the test scores are approximately normally distributed with a mean of 80 and a standard deviation of 7. Find the score of Frank if he is in the 75th percentile. That means Frank has a score of 0.7500. Find the z. The z-score associated with 0.7500 is equal to 0.67. I'm going to take that stuff and slide it over so I have a little room. Give me this. Come on over here. So my probability is 0.75. My z-score is 0.67. I'm finding x. Find the score of. So plug it in the formula. 0.67 is equal to x minus 80 divided by 7. Multiply by your 7. 7 times 0.67 is 4.69. Equals x minus 80, add your 80. So that's 84.69 for Frank's, oops, sorry, 9 for Frank's score. Holly, if she's in the 12th percentile, oh, sad Holly. Sad Holly, her percentile is only 0.1200. So her z-score is negative, it's low. Her z-score is negative 1.17. So again, I'm given the percent, I look in the body of the table, find the closest thing to 0.12, it's negative 1.17. Now, I gotta plug it in. Negative 1.17 is equal to x minus 80, all divided by 7. Multiply, sorry, that's an 80, not an 86. Multiply by the 7. I get negative 8.19 is equal to x minus 80. Add your 80. So Holly's score was 71.81 to be in the 12th percentile. All right, one last example. Here we go. New lawnmowers life are normally distributed with a mean of 10 years and a standard deviation of 4. Mean of 10, standard deviation of 4. The company will repair or replace a lawnmower that breaks down if it is under warranty. If they do not want to fix or replace more than 20% of them, how long should the warranty be? So they want less than. They do not want to fix more than, which means they want less than 20%. So you don't have to flip your curve at all because you're already measuring underneath the 20%. So your probability here is 0.2000. So now what's the z-score associated with 0.2000? And you get negative 0.84. Okay, great. The question is, how long should the warranty be? That means you're finding x. So plug it in the formula. Negative 0.84 is equal to the mean, or the value, whatever x is, minus the mean of 10 divided by the standard deviation of 4. Work your way out of it and get x by itself. So 4 multiplied on both sides. 4 times negative 0.84 is negative 3.36. X minus 10. Add your 10. Add your 10. You get 6.64 is equal to x. So they don't want to repair anything that breaks down in the first 6.64 years is really what that is. So what you need to think of is, what does that mean for your warranty? You kind of want your warranty to be about 6 years. And the reason I'm rounding down there is because if they go up to 7 years, then you're going to have that many more lawnmowers that break down, because you're at 6.64 to get to the 20%. So I would say they're going to stop it at 6 years, because their business sense is going to say, I don't want to go to 7 years, because at 6.64, I get more than 20% that break down. You want less than 20%. So, all right, whew. Whole lot of examples today. Thanks for hanging in there with me. If you made it all the way to the end, congratulations. We will talk more on the review day. Have a great day.